Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 5, Lesson 8, Revisiting Percent Increase and Decrease. So in our unit on percent, we did a lot of problems where we took a quantity and we increased it by a certain percent of the original, or we decreased it by a certain percent of the original. And that always took two calculations. The first one being finding the actual percent increase, and then adding it to the original so that we got the final, and vice versa with the percent decrease. Today's lesson, what we're going to try to do is figure out how we can do it with a single calculation. Now, before we do that, strangely enough, we're going to review some basic ideas about factoring. Yeah, factoring. So let's get into that in the first problem. All right, basic factoring review. Exercise number 1. Write each binomial as the product of its GCF with another binomial. These may seem repetitive, but make sure you understand why they factor the way they do. All right, this is very, very important. We just got done with a lesson on factoring binomials. And whenever we factored a binomial, and let's take a look at letter A, right? We would take a look at the two terms, or at least the two numbers in the two terms, and we'd say, all right, what's the greatest common factor of these two numbers? Which again is easiest maybe to think about as what's the largest number that divides into both. Well, in letter A, it's very easy because both of those numbers are 5, right? So the GCF here equals 5, right? So if I want to write this binomial, 5 plus 5 times n, as in factored form with this GCF, it might be good to think about it as 5 times 1 plus 5 times n, right? And I know, you normally don't think of 5 as 5 times 1, but it really is, right? That is what the number 5 is. It's 5 ones. It's 5 times 1. But now it's pretty easy to factor this because I can write that GCF down, and then that leaves me with 5 times 1 plus n. All right? So that's the way this particular binomial factors, 5 times 1 plus n. What I'd like you to do now is pause the video and factor letter B and letter C. They're going to be pretty easy because, again, in all the cases, the two numbers are actually the same number. So pause the video and see how these factor. All right, well, again, when I have 150 plus 150 times r, right, I can look at this as 150 times 1 plus 150 times r. And you don't really even have to write this step out, but I can then take that greatest common factor, factor it out, and write this as 150 times 1 plus r. Subtraction works no different, right? If I have 20 minus 20p, the greatest common factor just is that 20, so I can look at this as 20 times 1 minus 20 times p. I can then factor that 20 out, and I'll be left with 1 minus p. Now, it'd be very understandable if you're wondering right now why it is that I always had the variable second, right? So most of the time when we were doing these kind of factorings in the previous lesson, the variable would kind of come first. We might have something like, 5x plus 5, and then I'd factor that into 5 times x plus 1. Well, again, it shouldn't really matter what order the numbers versus variables come in, right? The plain fact is, if I can identify that GCF, then I should be able to factor it out. All right, now for the remainder of the lesson, it's going to be important that you've got your calculator on you because we're going to be doing some messy division that's going to involve some decimal, or at least some decimal results. You don't want to have to do that longhand, so make sure you've got your scientific calculator ready to go. That being said, let's move on to exercise number 2. Here we go. Let's do a percent increase problem. Exercise number 2. Jason currently earns $340 per week at his father's car washing business. Next month, Jason will be getting a 5% raise. Letter A asks us, by how much will Jason's weekly salary be increasing? Show your calculation. All right, well, I'd like you to pause the video right now and see if you can remember how to find 5% of 340 just using a product involving a decimal. Why don't you go ahead and do that now? All right, well, hopefully you remember from the previous unit on percents that we can actually find 5% of 340 by simply taking 340 and multiplying it by 0.05. And again, this is kind of where the calculator comes in handy. You know, you could certainly do that by hand, but it takes a little bit more time. So I'm just going to do 0.05 times 340, or 340 times 0.05. It really doesn't matter. And we find 17. Now again, keep in mind that what that 17 represents, that actually represents Jason's raise. Okay, so his salary is going up by $17. Now, a very, very easy question is letter B. What will Jason's new salary be after the amount in A is added? Well, let's just do this one together. There's no reason to pause the video on this, right? Well, his old salary was $340 plus his raise of $17 means that he's got $347 as his new salary. Uh-oh, not 347, that's weird. Maybe I should have used my calculator on that. Let's try 357. Okay, I think that's right now. All right, let's now take a look at letter C. Let n be a single number that we could multiply Jason's $340 salary by to find his new salary. Set up an equation and solve it for n. That should be set up an equation. All right, so let's do it. Right, this is actually a great place to use algebra. We know that his original salary is $340 and his final salary is $357. So what we want to do is we want to set up and solve this equation. Well, we don't want to set it up and solve it. I already set it up. But it's very simple, right? If I want to figure out a number, n, that I can multiply his original salary by to get his final salary, well, that's the equation I need to solve. Why don't you now go ahead and solve it with the help of your calculator? Pause the video now. All right, well, this is a simple enough problem to actually solve, right? We're just going to divide both sides by 340, and this is why we want to have that calculator handy, because that is certainly not a division problem I want to do longhand. And I can now just do 357 divided by 340. And we actually get kind of a nice answer, 1.05. All right, now just for a moment, I want you to look at the answer we just got there. We're going to explore this more in the next part, in part D. But we could have multiplied his original salary by 1.05 in order to get his final salary, and we could have done it in just that one calculation. The question is, why, right? So let's take a look at that in letter D. Write Jason's new salary as the sum of his current salary and the decimal rate times his current salary. Then factor this expression and compare to C. All right, so here is the power of algebra, if you will. Algebra that has no variables involved at all, right? Really, what we did to find his final salary is we took his original salary, 340, and we added to it 340 times 0.05. Now we did that in two steps, right? We did it by first calculating this and then adding it on to this. But look, this structure, a number plus the same number times something, is exactly the scenario we had in exercise number 1, right? When you look back at that, the only difference between this structure and those in exercise number 1 is that we always had a variable here. It was n or x or r or whatever, p, right? But here it's a number. That's fine. All variables are numbers you don't know. So if I wanted to factor this, right, I could now think of this as 340 times 1 plus 340 times 0.05. We can now see a 340 as a GCF that I can factor out, and it would be 340 times 1 plus 0.05. Now, the problem also asks us to take this and compare it to this. Well, look, that's exactly what we got, right? Letter C asked us what number could we multiply 340 by to directly go to the 357, and the answer was 1.05. But that's what we have in here, right? 1 plus 0.05 is 1.05. So it appears that to raise a particular number by 5%, all you have to do is multiply by 1 plus the decimal version of that percent. Let's try it a little bit more in letters E and F. All right, letter E. Jason's father makes $820 per week. You might think that's unfair, but remember, it's his car wash business. Jason's father makes $820 per week from the car wash. If he also gets a 5% raise, use what you found in C and D to calculate his new weekly salary. All right, so I claim that we can actually take Jason's father's salary, 820, and just multiply it by 1.05, and that will give us his new salary, and that new salary will actually be 5% larger than his old salary. Let's see if that's actually true. So this is simple enough. Let's just take our calculator. We'll take 820, and we'll multiply it by 1.05, and we get $861. All right, 861. Now, letter F says verify that his father's new salary is a 5% increase over the original $820. Show your work. Now, this goes back to actually how you calculate how much something has increased. You know, what percent has something gone up, right? So we can verify that, in fact, this is 5% more than this by doing the following. We can say, well, we have 861 minus 820, which is 41. Now, remember, that 41 actually represents his raise, right? He got a raise of $41. And we want to compare that $41 raise not to the 861, but to the 820, right? So I'm going to do 41 divided by 820, right? So this is literally his percent raise. And I'll multiply that by 100 to sort of, if you will, turn it into a percent. So let's take a look. If we do $41 that he got as a raise, divided by his original salary, remember, the original is always the whole. That's 0.05 times 100, and that is a 5% increase. Right. So it appears, right? It appears that what I can do is simply to raise something by 5%, to make it go up by 5%, I can multiply by 1 plus 0.05. In other words, 1.05. Let's make sure, though, that this pattern works regardless of what the percent raise is. You know, here we only dealt with a 5% raise. Let's take a look at another percent increase problem. Exercise number 3. A liquid starts at a temperature of 75 degrees Fahrenheit and increases its temperature by 32% as it heats up. Find its new temperature by finding 32% of 75 and adding. All right, so in other words, I want you to do letter A kind of the old-fashioned way. I want you to find out what 32% of 75 is, you know, then take that, which is how much the temperature is going to go up, add it to 75 to get the new temperature. Pause the video now and go ahead and do that. All right, well, here we go. We want to take our 75 and we want to find 32% of it, so we're going to multiply by 0.32. Let's see what we get in that case. 75 times 0.32, enter, gives me 24 degrees. All right, now remember, that is how much it's going to go up. So now if I want to find the final temperature, I'll take 75 plus 24. Let's see if I can get this correct this time. And it looks like the new temperature is 99 degrees Fahrenheit. All right. Now again, my whole goal this lesson is to not have to do this in 2 calculations, to do it in only 1. So letter B, just like before, asks us to do the following. Find a single number you could multiply 75 by to find the new temperature. Does the pattern hold? So again, same idea. Let's do this one together, right? If I wanted to find a single number I could multiply 75 by in order to get that 99, I would solve that by solving this equation. 75 times n equals 99. I can then solve this equation by dividing both sides by 75. Right? And again, this is what that calculator is all about in this lesson. 99 divided by 75 equals 1.32. The question is, does the pattern hold? And the answer is absolutely, right? Because what was the number that we could have used? 1.32. And of course, we can think of 1.32 as 1 plus 0.32, right? So that raise of 0.32, right? The raise in the temperature, right, can sort of be found all at once, our new temperature, by multiplying by 1 plus 0.32 or 1.32. You can really think about it as I've got 100% of the original temperature plus 32% of the original temperature as well, right? I always get to keep what I started with plus another 32%. All right? Let's see how we can now do this in general. All right, here we go. Exercise number 4. State a number you could multiply by to increase a quantity by each of the following percentages. All right, this is cool. So again, like if I was asked to raise something by 18% or increase something by 18%, I could certainly multiply it by 0.18, get an answer, and then add that on. Okay, I could do that in 2 steps. Or I could multiply by the following: 1 plus 0.18, which is 1.18. This will increase whatever quantity, a temperature, a salary, the number of people in a high school, whatever. This will increase it by 18% if I multiply by 1.18. Now, these can be a little bit tricky, but especially if the percents kind of get like that. So pause the video now and see if you understand what's going on here. Tell me a number in each case that you could multiply by to increase something by that particular percent. All right. Well, you got to watch out, right? Because it would be tempting to say 1.7 for 7%. But in fact, right, 7% is the same as 0.07 as a decimal. And therefore, to raise something by 7%, I would multiply by 1 plus 0.07 or 1.07. Again, I'm getting 100% plus another 7%. 85%, that's pretty easy, right? 85% as a decimal is 0.85, and therefore I could multiply by 1 plus 0.85 or 1.85 to raise it by that amount. Now, maybe the hardest ones are things like this, where you have something like 2.5%, 3.25%, whatever, right? Now, if that's a struggle for you, if you put down 1.25, which is the wrong answer, what I would always suggest doing is taking that percent, right, and just doing something like, doing something like this to it. I just moved all those up. Just take that percent, do something like this, 2.5 divided by 100. Well, that didn't do it. Didn't get that division bar. 2.5 divided by 100, right? And that's 0.025, right? So now the number I should multiply by is 1.025. Quite frankly, you could really summarize all of this by just saying, yeah, you should always multiply by this. in order to increase by that percent. So if I want to increase by 8%, I would multiply by 1 plus 8 divided by 100, or 1.08. You know, something like that's easy. It's a little bit harder when you have something like 2.5%. So this is kind of a nice way to look at it. Now, that's percent increase. What about percent decrease? That gets a little bit more challenging, but you should be able to understand it exactly the same way. So let's take a look at that. Exercise number 5. A container originally holds 250 gallons of water. After 10 minutes of draining, its volume has decreased by 8%. Letter A, find the new volume of water in gallons by finding 8% of 250 and subtracting. Right, so now we have a subtraction process going on because we're decreasing. So why don't you go ahead and do letter A, find the new volume of water after you've decreased the 250 gallons by 8%. All right, let's do it. So simple enough. First things first, I had to find 8% of 250. So I'm going to multiply 250 by 0.08. And let's take a look at what that is. We've got 250 times 0.08 equals, that's 20 gallons. Now, of course, that's the amount that it's going down. We still have to figure out what it's at. So we're going to do 250 minus 20, and the new volume is going to be 230 gallons. Now, just like before, though, I'd like to be able to do this calculation in one step, not two. All right, so let's take a look at letter B. Let n be a single number you could multiply 250 by to find the new volume. Set up and solve an equation for n. All right, this time, why don't you try it on your own? Go ahead. All right, now you have to be careful because in this case, right, we're taking this sort of larger number, 250. I'd like to multiply it by n to get my new volume, 230. So this is the equation I need to have set up. 250 times n equals 230. To solve it again, a simple one step gets the job done. I'm going to divide both sides by 250. And I'm going to find that n is equal to the following. 230 divided by 250 equals 0.92. Let's bring that back down here. Now, that's kind of cool. Think about this for a second. We lowered our temperature by 8% by multiplying the original one by 0.92. Right? So what really is the connection there? Well, let's take a look at that in letter C. Why does the number from B make sense? Can you use the distributive property, like we did in exercise 2D, to see why? All right, so think about this. Why was the number that we multiplied by 0.92? Forget about the algebra and factoring and all of that. Pause the video now and see if you can find some kind of connection between 0.92 and the fact that it went down by 8%. Go ahead and pause the video for a second. Well, the plain fact is, if you think about it as starting with 100%, right? If you think about starting with 100% and subtracting off 8%, then what you have left is 92%, right? So really what we're doing here is we're kind of going in exactly the opposite direction of what we've been doing so far in this lesson, which is instead of adding a percent to 100%, we're subtracting something from 100%. And in fact, this is the way the algebra works out, right? We've got that 250, and we've subtracted 250 times 0.08. And just like before, what I can now do is I can factor a 250 out, and I'm left with 250 times 1 minus 0.08. Now, it's pretty easy to see things like 1 plus 0.08 is 1.08, or 1 plus 0.03 is 1.03. 1 minus 0.08 that takes a little bit more thinking, right? But if you think about this as like 1.00, you know, sort of like 100 minus 8, right? And if you can't think about it that way, of course, you could always take your calculator out and just do something like this. 1 minus 0.08, enter, and that's 0.92. Right? But that's simply the pattern with decrease, right? Instead of adding the decimal rate to the number 1, you're going to subtract the decimal rate from the number 1. You're always starting with 100% of whatever. And then you're either adding a percent to it, if you're increasing, or you're subtracting a percent from it, if you decrease. Let's finish this one off, right? So now, exercise number 6. State a number you could multiply by to decrease a quantity by each of the given percentages. So, right, the basic way of doing this is to say, all right, well, 3% is 0.03. All right, so if I want to decrease something by 3%, I'm going to do 1 minus 0.03. Right? So I'd have 1 minus 0.03, and that means I'm going to multiply by 0.97. The other way, though, right, the more sort of, if you will, common sense way is to say, look, if I'm going to decrease something, if I'm going to decrease something by 3%, that means I'm going to have 97% left, right? If I started with 100% on a test and I lost 3%, I'm going to have a 97% left, right? So I multiply by 0.97. Think about it this way with the 12%, right? If I started with 100% and I decreased by 12%, I would have 88% left. So I would multiply by 0.88. Now again, if that doesn't work for you, you can always say, all right, 12% is 0.12, 1 minus 0.12. You could then do that on the calculator if you needed to, and that would be 0.88. All right, what I'd like you to do is finish this problem off by figuring out what number you'd multiply by in both of these cases to decrease by that percent. Pause the video now. All right, well, we had a pretty easy one and maybe a more challenging one, right? If I decrease by 25%, that means I have 75% left, which means I'd multiply by 0.75. Or, again, just the purely mechanical way of doing it, 25% as a decimal is 0.25, 1 minus 0.25, and that's 0.75. If I want to lower something by 25%, I simply multiply it by 0.75. We're multiplying it by the percent that's left, right? What percent is left over? 75%, so I multiply by 0.75. Now in this case, I'm lowering something by 0.5%. And again, that can be a little bit tricky, right? You know, when the percent itself involves a decimal. Now again, the cool thing is, if you lowered it by 1%, you'd be at 99%. If you only lower it by 0.5%, you'd be at 99.5%, meaning you should multiply by 0.995. Again, if that's a problem for you, right, then you take your calculator out, you say, all right, I need to figure out the decimal version of 0.5%, so I'm going to take 0.5 and I'm going to divide it by 100. All right, and that's going to be as a rate 0.005. I then do 1 minus 0.005. Let's do all of this on the calculator just to show you the whole process, and that would be 0.995. And that's it. And it's really nice, and it's really important. When you get into 8th grade math and into Algebra 1, we're going to want you to be able to increase and decrease a number by a certain percent with this single product, right? We're not going to want you to multiply, get an answer, and add it on or subtract it. We want you to be able to do it in one single step. All right, let's summarize. Right, so We did a lot of work in a unit on percent with percent increase and percent decrease. We did a ton of work, and we always did it in 2 steps. Okay? But in today's lesson, what we saw is by thinking about factoring, we can actually understand why you can increase or decrease a number by a certain percent using the product that involves just a single number. In the case of increasing, we always do 1 plus the decimal version of the percent. And in the case of decrease, we always do 1 minus the decimal version of the percent, right? Those numbers then, when you multiply the original, will either raise or lower by that given percent. All right, and then again, boy, do you use this a lot in future math. For now, though, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.